Now let us study about the other types of distinction, that is reaction with chlorine water, also known as catalytic dehydrogenation. When alcohols are treated with chlorine water or sodium hypochlorite or bleaching powder solution, they get oxidized. Oxidized in the sense the addition of oxygen. Primary alcohols are oxidized to aldehydes. That is, we already seen that ethylene glycol alcohol on oxidation results in the formation of acetaldehyde with water. Secondary alcohols are oxidized to ketones. Let us take an example, isopropyl alcohol. On addition of oxygen, we obtain a ketone, namely acetone, and water as a side product. Tertiary alcohols do not undergo this reaction because it does not contain any alpha hydrogen which is involved. For example, let us take a secondary alcohol. This hydrogen here is known as the alpha hydrogen. In a tertiary alcohol, this hydrogen won't be present. Instead of this hydrogen, we'll be having an other aryl groups or alkyl groups. Therefore, since due to the absence of alpha hydrogen, the tertiary alcohols cannot undergo oxidation reaction. The carbonyl compounds formed undergo further chlorination, forming chlorinated aldehydes and ketones. Acetaldehyde on the addition of chlorine forms chlorol. Acetone forms trichloroacetone. Since this is a positive test for both acetaldehyde and acetone, when alcohols containing the acetone group is treated with iodine and potassium hydroxide, yellow crystals of iodoform is formed. The triiodocarbonyl compound formed is decomposed by the alkali to give iodoform and potassium salt of an acid. The structure of triiodo is as shown here. Now let us take an example C2H5OH, that is ethanol. On addition of iodine in the presence of a KOH, we obtain an aldehyde. On further iodinization, we obtain a ketone, and addition of KOH results in the formation of CHI3, which is known as haloform, and HCOOK. Similarly, on addition of I2 and KOH for an increased number of carbon atoms, we obtain the same result, haloform, and a bigger CH3COOK product. The formation of haloform in general by this procedure is called haloform reaction. Since methanol does not contain CH3CHOH, that is acetone group, it does not undergo haloform reaction. Dehydrogenation of alcohols by passing the vapors over heated copper at 573 Kelvin. This is the passage for the heat to go in. The heat first entered will be along with moisture is evaporated in this evaporator region. Further on, the vapor is allowed to flow here, and this adiabatic section absorbs the heat with the passage of capillary tube here. This allows the liquid to flow and then condenses the vapors present and lets the heat out. Thus the dehydrogenation of alcohols are passed by the vapors over heated copper. These are generally conducted at the temperatures of 573 Kelvin. Generally, absence of alpha hydrogen in tertiary alcohol and other above condition leads to only dehydrogenation of olefin. As we have already seen, primary alcohol in the presence of copper catalyst and 573 Kelvin will form an aldehyde along with hydrogen gas. Similarly, a secondary alcohol in the same catalyst and conditions obtains ketone and hydrogen gas is evolved. But in the case of tertiary alcohol, we won't obtain any aldehydes or ketones. Instead, dehydration process occurs and we will obtain a product, isobutylene, and water as a side product.